welcome back. So in this segment, we want to talk about why are there different parts to a solar system. We said that the inner part of the solar system is composed of rock and metal, and then the middle part is composed of a lot of gases, and then the outer part is composed of ices. So we want to figure out why did that happen. So where we're at right now is that we do have a disk, and this disk is going to consist of a uniform mixture of rocks, metals, ice, and gas. So the rocks and the metals, I'm going to put them together and just say the letter R, and then ice is going to be given by the letter I, and then gas is going to be given by the letter G. So if you look, you'll notice that all of these different kinds of materials are evenly distributed throughout this disk. And then in the middle, that red dot, that's going to be where the sun is going to be. Now at this point, the sun has not ignited yet. So there's no thermal nuclear explosions that are going on, but it is getting hotter. So this proto-sun, this thing that's going to turn into the sun, starts to give off heat, and that's going to have a big impact on the formation of the solar system. So what's going to happen is as the sun heats up, it's going to form a frost or an ice line, and that's that blue line in that picture there. And what's going to happen is that the rock and the metals will be able to survive close to the sun because they just don't tend to melt at very low temperatures. So if you, let's say you've got a hot plate and you put a cube of ice on it, and then you put a rock on it, and then you put a piece of metal on it, and you start to turn up the heat, well, which is the first one that's going to melt? Well, it's going to be the ice. So what happens is that the ice in the inner part of the solar system is going to be driven away because of the heat that is being emanated by this thing that's going to become the sun. So the ice doesn't melt, it doesn't change from a solid to a liquid, but it does change from a solid into a gas, and then that gas is kind of blown into the middle part of the solar system. Anything inside that blue line, anything inside the ice line, ice will not be able to exist. It will have to go to the middle part and the outer part of the solar system. Now, what about the rocks and the iron? They're okay. So this would explain why you have the inner planets, so that's going to be Mercury, and then Venus, Earth, and Mars are composed of rock and metal, is because they could survive close to the sun. Okay, got it? Okay, let's go on here. And in this picture, you'll now notice that the ice is in the outer part and the middle part of the solar system. But if you look at the difference between this picture and the previous picture, you'll notice that the pieces of rock and metal are starting to coalesce and are starting to turn into planets. Now, we would still call these things protoplanets because they're not full-fledged planets yet, but they're getting there. So as these dust particles collide, you might start off with trillions and trillions of dust particles colliding, but then after a few million years, well, maybe you're down to billions of particles that are about the size of my fist. And then after a few more million years, now you've got millions of particles that maybe they're the size of a house. And then after another million years, now you've got thousands of things that are the size of a city. So as these things bump into each other, they're starting to stick together and are starting to form larger and larger structures. Now, at first, the dust doesn't stick together because of gravity. So the original reason why this stuff starts to stick together is static electricity. So it's been described as dust bunnies. So you clean underneath your bed, everything is spotless underneath the bed, and then you look under the bed 6 months later and you find all these fuzzballs. So what's happened is that dust and pieces of hair and skin and all of this other stuff floating in the air, when they come together because of electricity, positive and negative charges attract, and this makes larger and larger collections of dust and hair and stuff. So we call that a dust bunny. So similarly, the teeny tiny little pieces of dust initially stick together because of electricity, and then once it gets to a certain size, about the size of a basketball, then gravity starts to become the dominant force in pulling all of this material together. So now let's take a look at what we're left over with. So notice that you've still got gas basically all over the place, and you have ice in the outer and middle part of the solar system. But notice now there is no ice in the inner part of the solar system. It's been driven off. And you notice that the dust, the rock, the metals have all collected into planets. Now there's still a lot of rock and metal floating around out there, but for the most part we have now formed our protoplanets, the things that will eventually become the planets in our solar system. Okay, let's take a break, and then when we come back, we will talk about where the Jovian planets come from.